Okay, you should be live here. Hello. I just need to mess with the Twitch setup. Okay, we should be set. Let me open the restream page real quick, and I will switch the view over. Yeah, we should be good here. All right, so here's the deal. We received a rather small little PR that I wouldn't normally take much notice of, but was it even a PR? No, I got an email. That's why I noticed. And it was just somebody saying that they made our generalized advantage kernels a little faster. Okay, cool. Oh, that's not probably worth my time, but we'll see. Let's just see if I grok pulls in that change if it does anything. And I kind of figured like GAE is not really a significant amount of the training anyways, but maybe there'll be something useful there. And it was very useful, even compared to our now optimized path, which was very odd. I want to follow what you're doing. What video do I start with? We have articles on X, but other than that, it's just the live stream, pretty much. My RL iceberg video is pretty nice though for totally new people. That's on my main page. Um, okay, so yeah, this update here, it made the GAE a bit faster, but the curve of the performance was kind of interesting. So I figured like, okay, let's try this on Mingru. Not really expecting much because we tried this quite significantly before. But evidently, I think we just messed something up before. So let me see something here. Where is this? Puffer C. Okay, it didn't mess with this, I suppose. What is this? It's just T equals 512, right? Added about 400 lines. We're gonna see. Does Where's this scan? Down here? Yeah, row. Interesting. It's very weird. We probably Jeez, that's really good perf, isn't it? I mean, that's kind of ridiculous. 38 mil. But this is just our base. And then the question is the degradation. We have to see the degradation, right? I suspect this will be one of those improvements that we do need. This adds quite a bit of code. Okay, this is also... We're gonna have to determinize this. Yeah, this is just... Is this all just a big fancy reduction? This would matter a lot, though. We don't need all this advantage scan. This should be fast regardless. Yeah. It's still a pretty big upgrade. That's like several mil SPS. Well, I wasn't going to be working on core, but somebody sent an interesting PR that I thought, oh, okay, that's interesting. Let me try this on something else. It looks like we somehow have a scan kernel that works on Mingru. So presumably... Yeah, okay. I don't understand how this happened though, because I tried this several times, and several other people tried this several times. This is so weird, man. Let me see if I can figure this out. It's a pretty complicated operation. I mean, I can see this is isn't this the whole gate? I think so, but it's very weird because we've tried parallel scan several times in the past and it has not helped. And then this was immediately faster. Pre CUDA? No, we tried this on the full CUDA version as well. There's something that's different here. Basically, what happened is somebody submitted me some clever JE kernel that had a scan operation type thing in it, and it is faster, but not that significant. Though actually, it is maybe significant here. 25 mil. There's something weird here because the times don't add up. Yeah, that definitely there's something wrong. We'll see. Hopefully this is correct. I mean, I guess I don't really mind either way. If this is correct, then we get a very nice speed upgrade. If this is not correct, then we've like once again confirmed that this is not doable, and we keep the current simpler design. Okay, so now it's being stupid. Actually, it's 30%. I will look at them. Thank you, Convert. I'm on there's some weird optimization that we might be able to do here. Could be quite actually could be quite important. Because this would essentially would this fully let us use hmm, nice. San Diego. I didn't think we had this amount of overhead. Somehow this is showing a big training speed up. It's suspicious, but if it's real, it would be really good. Interesting. I'm still not entirely sure. How many launches is this? Well, I want to check this thing just to see if last minute we have a massive perf win for free. That would be cool. Um, but aside from that, pretty much just need to sweep the environments and clean up some configs and stuff. Constellation, some constellation tweaks. Got to clean up the puffer mascot with that, but like pretty simple stuff. We're definitely on time. Yeah, this is true. I really should just see if I can figure. Hang on. So block. Do we break up the horizon into chunks? I tried this. I swear I did. Right? Man, I could swear I tried this exact thing. It's just, so you have blocks, right? Yeah, chunks. And then... Huh? Okay, no, I don't... Oh, wait, that's the backward. That's why I don't understand that. Cool. No wonder. Okay, so here are the chunks. How is it doing? This has to be the opt for one chunk, right? And then a single combine, maybe? No, I don't understand this. I don't understand this, Colonel. Hey, Val. Hey, Valo. Oh, I can chat about, Inferno Env today. And Kahlo. I got kind of side-sniped here, because, somebody sent a PR that I then applied to something else that has, it looks like a big perf boost. Okay. This is reasonable. Yeah, well, it's kind of weird in a sense. No, this wouldn't even be on here. That is pretty nuts. Tomorrow's good. Tomorrow's good. Ryzen's only 64 on this one. What's another env? Does the PR? So they didn't PR this. Like, the thing is, I got an email essentially from somebody who'd written some Triton kernels that they said are faster than Puffer's JE kernel above seek length 32, which, like, okay, fair enough, but we don't really care because that's a tiny amount of our compute. But I figured I'd just see if they did anything interesting anyways, and they have this sort of interesting block scan structure. Um, So I just had Grok like, hey, see if this thing actually works for our Mingru kernel, which is way, way, way more important. And it seems like it does. Doing well? I'm doing pretty well. I'm doing pretty well. I got some rest since this weekend. Run a couple of 10Ks. And I'm doing pretty well. We'll see if this is significant. Even if it's a 10% on this, that would be pretty impressive. And again, I think that the policy going forward from 5.0 is going to be that we do not accept like complexity and crap into Puffer in order to improve the performance of models that are below 100k parameters. Test if the math matches. Of course we're going to test that. I mean, we'll just train the thing end to end, right? Even better. Yeah, it's a model-bound training setup. So quite possibly this could be an end where it helps. We also, hopefully, it's not, like, reliant on something that we can't do because of determinism. We will see. We got Valozen slated for tomorrow. I do not find unit tests are better, frankly. And generally, when we do unit tests, we treat them as throwaway. They tend to lock the design far too much for my liking. It is easy to regress, but we also have a whole bunch of ends. There's sometimes where we can literally just check that it's bitwise exact versus the original, but then CUDA does not give you, it gives you limited determinism guarantees. So, Puffer's already basically as deterministic as it's possible to get it, as it's possible to make CUDA be. Or at least cuBLAS. If this works, it would be pretty cool. Suppose, yeah, this could be a significant bit of overhead even for reasonably sized models. Prod is the test. Yeah, I mean, we test some stuff, don't get me wrong, but I've always felt that maintaining a big set of unit tests locks you into a specific, not even architecture, but it basically just freezes your code much more heavily than not having a bunch of unit tests. And I've always found that the best way to reduce the number of bugs in the code is to always have it be as compact as possible. Two runs give exact same. Yeah, in current Puffer, you get bitwise identical results out of two different runs as long as they're on the same version of CUDA. It's one of the things we spend a long time working to make sure of. Now, with this new kernel, probably not, and that's one of the things that we'll fix. And hopefully the sync mechanism is not where all the savings come from. We will see. One versus 1.2. 4.7%. Really? I would have expected better than that. So what, is it all map moles already by that size? Yeah, I do find unit test too granular. Why is this not faster? How many T-flops do you get? I mean, that's going to be completely dependent on model size and whatnot, right? We typically measure time to solve problem as well as peak throughput on a useful configuration. So one of the coolest numbers I can show you is that we have up to 63, 64 million step per second training on a config that solves breakout in about 900 milliseconds. So it's mostly like a matter of the perf curve at different model sizes. Like, you're obviously going to be bandwidth bound no matter what you do, but there's still a good amount of room for optimizations. T-flop's not super meaningful. Yeah, again, though, it's a totally different problem regime from larger models. Like, we're looking at between like 10,000 and 10 million parameter networks. This may still be worth doing. I think it is. So what this would be long T. I still need to understand what the hell this thing is. Best I can tell, it's some sort of chunk scan, but we did that before. Void scan, stupid. Yeah, no, we're just experimenting with this thing for a little bit. Then I'm going to try to understand what this kernel is doing and see, with a combination of Grok and myself, if we can actually make it nice and compact. Did they mess with this? It seems a little slower than it used to be. What are we linking here, convert? Doesn't have me logged in. Where did you put it? Is this just in the dev somewhere? Dev. Thank you. Oh, what? You link the points when you hover them? Or when you click them? The bar charts. Okay. I can see a version of this. 3D rotates nice. I think I probably would want to just pipe the like the magnitude of the star or whatever way up instead of drawing a circle. It just makes the point like really obviously bright. I think that'll be nicer with constellation. I think the thing overall is nice. And then here, I think we can get it similar. Yeah. I like the feature. I think I'll change the implementation of it a little, though. And then the T-SNE plot, I think we need to replace anyways. Unless we want to implement T-SNE in CUDA, which sounds awful. We'll get a look at the Constellation PR, though, for sure. We have a hyperparameter sensitivity visualization. Let's see, that's the one on the bottom right. Okay, it's not deterministic. Hmm? It broke something. Yeah, but the marginal distribution from the GP is bullshit is the problem. This is the thing that we found out early, is that you can't just take the predictions from the GP. You need to actually run the experiments. $54. Interesting. $38. This 1.2. It's a big swing, isn't it? Yeah, it's better from 64. Jeez. $30. Interesting. It is faster here. The break-even point's a little sketchy. Then if you go to like 256 or something, 25 mil, 28 mil. Still a meaningful jump. It might just be that it's the reduction, to be fair. So it doesn't need to be bit for bit identical with the non-blocked path, but it does need to be identical from run to run. Right. Okay, yeah. If that works, then it could be pretty good. Okay. We'll just have to test this. It's a lot of float buffers. It's worth spending a little bit of time on this in case it is a nice big perf boost. We will see. That would be pretty cool. If it is, yay. If not, no big deal. Worth investing a little time. And then after this, I think we kind of just start cleaning up configs, testing stuff locally, making sure everything is sane. Really, we'd like to get set up for the final sweeps for Constellation. Oh yeah, we can check convert stuff to Constellation. I also have to decide if I want to change. Well, I do need to change. I have to decide what I want to change for the bottom left panel. Okay. I suppose what we can do is in the meantime, take back what I said about unit tests. This is pure bare metal. Oh, puffer? Yeah, it's actually pretty cool. Let me show you something. Are we in the right branch here? Yeah. So this is our source. Ignore half of these files. This is all like me fucking around with stuff. Actually, wait, this is not at all the right branch, is it? Here we go. Way better. Okay, this is our source. It's 8 files, 10K lines total, 5,000 lines for all of our algo backend. So here's all our fancy network and stuff. And then here is all of our high perf infrastructure. And then we have 1,600 lines devoted to our visualization dashboard. This is pure C, and we can compile this for your browser. We have our own ini loader, and then most of the remaining code here is devoted to hyperparameter sweep. This is again our own algorithm, Gaussian processes in CUDA-C, and then our CPU evaluation backend. And that's pretty much all the code in Puffer. Our 4.0 release was 5,000 lines of CUDA backend, and then like several thousand lines of Python glue. Our 5.0 release gets rid of all the Python, and instead it's going to be 10K lines, CUDA and C. I find this dramatically simpler to reason about, honestly, than even like all the PyTorch mess we had before. Much, much easier to understand perf and what's going on. And the results have been very good. I mean, since we ditched PyTorch, we took what was already the highest performance RL library in existence, and we made it over 10 times faster, which is sort of ridiculous to think about. Sometimes I will let the model just like screw around with a kernel or something for a bit, but you'll see it's not going to be like, okay, insta commit this bullshit, right? Like, this would be, okay, now I know it's correct. Now let's spend an hour cleaning it up if we're actually going to keep this or not. Let's not make a mess of our nice code. Like, I spent several weeks getting it to be this compact. Here's our local breakout. This one's much slower. I didn't do CU. Some of these warnings, maybe. Okay, still 15 MSPS on my local, and this only has a 3080 on it. This is still fine. So, I suppose that on the local, possibly redundant hypers. Quite a bunch of stuff. Yeah, we have a lot of redundant parameters. Just dedupe this. Yeah, so this is what I was concerned about, that possibly the reduction makes it slower. I guess that would make sense, right? If it is actually pretty straightforward to have a good block scan kernel, but then at this scale, like, you can't get nice return deterministic reductions. It's still good. Fork. Nice. Cracked out PPO. It's a little better than PPO. It's actually it's kind of irritating. So, in our 3.0 update, we made some pretty significant algorithmic advancements. Um, but then in 4.0, because we came up with a fundamentally better architecture, two of those algorithmic advancements turned out to not really matter anymore. So it is now, it's essentially, it's cracked out PPO with muon and a fundamentally different architecture as well. It also does have a pretty nice stable async mode. It's kind of cracked out async PPO with muon, I suppose, at this point. I guess whether you consider it the same algorithm is kind of up to you, but I will say this. If you just go try to implement, like, the original PPO paper, but as fast as possible, you will not get remotely close to the same results as we have here. And then if you try to take some ideas from Impala, you'll get even worse results, because that paper doesn't even work. That was the finding from last week, unfortunately. In this case, it means very good. All right. This is I was meaning to do this for a while. This is just like a strip dead keys thing. One thing I can ask you all about while I'm waiting for this. So this is our new docs page. You see this is still local. Build SH breakout, puffer train, puffer eval latest. What do we think about that? And in general, what do we think about the usage of the library here? Make this larger. Is this simple? Is this good? Is there stuff we can improve with this? I kind of want to make this as intuitive as I possibly can for you all. And it's just puffer eval latest, yeah, like this. Yes, I did. I made it shorter. We're no longer constrained to argparse because it's not Python anymore. Technically, I don't even need the dash dashes anymore. We could omit the dash dashes, or we could do single dash. We should probably look up what is the canonical, like, we should probably match more, like, Unix CLI tools. Well, for full word is interesting. Yeah, but it's not like, we don't even have the abbreviations thing. No, I don't think you need a TUI. Single dash for dev, double for word. Okay, so then we match already. I don't really feel the need to give like a single letter headless or whatever. I think that this is fine like this without having like single letter for some stuff. Do you really think it would be nice? Like, are people going to remember? Because, like, keep in mind, Puffer, we don't ever make the promise that our commands and stuff are going to be stable for a long time. Like, we change stuff around quite often, just to whatever the simplest thing is under the current design. LC old. Yeah, it's... And also you have the entire, like, args like this, right? Okay, this is nice. This is nice. Anything in any of the sections can be set as a command line flag arch. This is at least not so bad anymore. Hello, Jess. I got a really funny email with a optimization for something that didn't super matter, and it looks like that optimization is turning out to be pretty major for Mingru. Comment in the docs could help. Uh, where is it? Yeah, you're right. I can do that. Hang on, this is the wrong one. Kernels. Okay, I can make that more explicit. Let me see what's here. Okay. A little tighter. At least this is no longer a disastrous mess. This is just like two rather complex kernels. Clean up some warnings. Interesting. I'm pretty sure you can paralyze H as well. We do some optimizations. Oh yeah. We do some optimizations. Though actually this might give us a way to do the seek kernel simpler as well. Wait, why the hell didn't I think of that? Am I a moron? Wait, why didn't I think of that? Wait. Uh Guys, did I miss out on a really obvious major optimization again? Okay, so like here no, wait, this one is mingru gate grid size B times H block size. No, we're already doing it here, right? But then what about this one? Are we not already doing this? I thought, wait. Mingru scan. Are we not already doing this? Huh. I think we are, no? Because I don't have a loop over H. How do I use the CPU weights to code physics? What do you mean to code physics solvers? I have no idea what you're saying. Hey Tim, welcome. We're looking at some kernels. What? The chat does not make sense to me at the moment. I think the thing I said didn't make sense. But then wait. Scan forward. Maybe this version does it wrong. Okay, so let's see. So we have a number of chunks. Well, of course, but I can't tell. Yeah, I can't tell if it's doing it already or not. So basically I can let this screw around, but we don't actually we shouldn't expect anything from this. The low child we're not familiar with. If you have something that you think works here, by all means. Um it's embarrassingly parallel embarrassingly parallel along every dimension except for T. And then T can be paralyzed in blocks. Okay, we don't expect anything from this anyways. You know. I see, because this is macroed. Puff backend. But it doesn't make sense to have this not be I see. Prefix pair. I've seen that. That one has too many layers though. Stream in dpast. Oh wait, start using puffer. Nothing's receptive spire and end, just the stream and it did set up today and started. Okay, very cool. Yeah, it's very fast. You can do a lot with the speed. And I think 4.0 was 4.0 was an update where we got a huge amount of speed by going from Torch to Kuda, but there were still a lot of growing pains and stuff. I think 5.0 is going to be the nice, clean, polished version where it really feels CUDA SC native, and there's just not a bunch of random janky stuff to deal with anymore. Interesting. I think we go with the simpler one. Wait, hang on. I'm genuinely not sure here. I need to spend more time looking at this. The good news is that this is a relatively small code change, and we can test this pretty cleanly. Could get inverted, but otherwise I think it's fine. Not terrible either way. Probably commit this once I run a couple tests. And we can probably play with a few things. Use the restroom real quick. When is 5.0 out? Sometimes in the next few weeks, I would say. Hmm. Actually, that's kind of good, isn't it? That any good? Actually, no. I hate that. Come to think of it, what did it even delete? No, that's not worth. What would we be pipelining, dude? Like how? Sequential workers. I know what it is, dude. I don't see how it's applicable. Buffers rebuilt. Okay. Working on publications. No. I don't publish anymore. There's not really a reason for me to. I will work on some blog posts for this release. Researcher. I graduated, man. It says MIT PhD in my bio because I got my PhD 3 years ago from there. I run Puffer now. And get their. You only do that if you're a professor. I have no desire to be a professor. You think professors would be able to be like sitting here writing code all day? Virtually no professors actually get to spend any significant amount of their time on code. They just get barraged by meetings and administrative duties and stuff to the point that they have zero time for independent work. Why are we having if one? Oh, okay, for testing. That's fine. That's fine. Well, basically, the only way I can have time for this, right, is by doing my own thing. That's why I did. That's why I started Puffer. Yeah, Puffer's a company. Thank you. Okay. Can't run this with launch blocking. That'll be a mess. Well, I guess presumably this is also just because the policy is quite big. Yeah, let's try this with like hidden size 256 maybe. That could be meaningful. Definitely not so far, Meister. I think it will long term. But either way, this needs to exist. No, we get clients. We're not just looking for sponsors. There's no real money in that. I mean, the pitch is quite simple. We build the highest performance, best reinforcement learning tools by multiple orders of magnitude. So if you're in industry, you have an RL project, you need a custom simulator, you need integrations with our tools, who better to hire to do it than us? We build ultra high perf dedicated simulators. We do custom research for problems that are kind of just on the cusp of current capabilities. And we also help prepare for advancements that we know are going to be in the next version or the version after. The new dispatch does not use row. Yeah, I mean, that's kind of how I see it. It's like, what on earth could I possibly be doing otherwise? I've kind of, in the last several years, watched my whole industry go to shit to the point that, like, the vast majority of people that I respected who were doing awesome research are now working on something utterly worthless because some LLM company has scooped them up and paid them a bunch of money. And if you need the money, like, hey, no shame on you by all means. But I mean, I've not spent the last 15 years of my life working on this stuff in order to just go do that. No, thank you. And the plan here is like, with 5.0, we have a really nice, solid, polished, fast version of the current set of capabilities. We need a few more benchmarks. We need to really understand the remaining gaps with what we can do. We're set up very well to do that. Maybe one last algorithmic push. And I think at that point, we just start building some really hard applied sims. We start really trying to crank on areas of science that are dependent on simulation for advancement using our tools. I mean, CV, I'm not unmotivated by money, right? Like, there is a business side to this as well, and that's important because it also lets me hire more people that I know are really good, push the research forward. Plus, it's good to have some cash in the bank. But, I mean, not at the price of not being able to build the stuff that I know needs to exist. That is also true, Meister. That is also very, very true. It's often used as an excuse. And the way that you can see that is that they don't quit after 2 years. Do LLM and get the money. Yeah, but that would have been miserable. I think I'd honestly rather hang out with your average, like, bloke in a rural bar in Alabama than I would with, like, your average SF tech bro. So, this is also just way more enjoyable. Well, not this, not the staring at stupid grok window portion. Obviously, there are going to be portions of building a thing that are just kind of boring and annoying, but the overall process for sure. Hmm. Okay, this is much better. This is actually... Wait, why is it 10%? 10% would still be good. Don't get me wrong. Why is this only 24%? Oh, Matmul's already 60. Okay, that's not terrible. Ingrew. So this architecture is a product of our own research. It's completely custom. It is a combination of Mingru, which is a simple linear recurrence, and highway connections, which is, well, from a very old set of papers and something that I used in my first ever published paper. The key here is that highway connections prevent you from needing layer norm, and layer norm is very, very slow and unwieldy, especially for small models. We actually, if you check my Twitter, at J Suarez, there's an article on the architecture. How much faster is 5.0 versus 4.0 so far? The peak speed increase is over 3x. I think a lot of problems are going to get like a 1.5 to 2x boost, with async especially. This is supposed to be a smaller update than 4.0, and it is, but it's still good. We'll call this a roughly 10% on average improvement. I think this is a roughly 10% on average. Don't listen to music while I work? Well, I have the chat here, and then I also have one, two. I have plenty of distractions as is, believe me. I'll usually close at least one of those if I'm doing something that's much more attentive. The bottom lull. I mean, we could do it if Riot's interested in that. It'd be a big project, but we could do it. Likely not on A5090, but with enough simulation engineering, likely we could do it on 85090s. An ad. I'll wait for that to finish and strong weights. What? Strong weights? I have lots of articles on X. It's at J Suarez. Just my last name. J, my last name. On X, the articles tab. Oh. Huh. Interesting. So this actually is not a scan, really. It's parallel loads. Interesting. Wait. Having an approx M for training. Fine-tuning on an exact... We do, but the most convincing example that I have of that is not something I can share publicly. It takes a bit of work, I will say. But yes, that does work. I don't think if we have any good examples. I mean, you can look at the drone env, I suppose. The domain randomization and such in there is quite nice, and you can actually run that on a real drone. Finn has some demos. Okay, I'm happy with that explanation. It's over 10K again. We'll have to cut a few things, but no biggie. I saw the demo earlier. Rich Sutton's. What demo? I've been pretty bearish actually on a lot of. Obviously, the guy's a legend. But I've been pretty bearish on some of the ideas he's had lately. Oh, the drone video. It's kind of weird for him to like split with Carmack as well. Carmack's pretty awesome. Okay, this is good. Nice. Okay, we're good. All right. That's nice. Agenda for today? Well, we just merged a pretty nice improvement. That was optimal. Optimal configs DT. What is the idea behind such sweeps? How many steps do you usually per sweep in all? So typically we start with like a reasonably sane config that does something, and like the amount of steps that is run, the model size, the hypers, all of that is determined automatically by protein. The algorithm is very good. It attempts to get the highest performance for every fixed amount of compute you could spend. So it'll see what's the best run I can get in 10 seconds, in 20 seconds, in 30 seconds. And it also biases such that it won't just keep running really long experiments if there's not a benefit to them. So an experiment actually has to be better, that is longer before it'll go more than that. What did I merge? I got a funny email with a potential improvement to one of our kernels, which did work, but did not end up really mattering. It was like a less than 1% performance improvement. But then we were able to use the same technique on something that was more important, and we were able to get like 10%. Not on everything, mind you, but on a lot of our configs, it'll be around 10%, and some of them it'll be much more than that. Okay. Let's go check what Kinvert did in this PR. We'll see if he listened, because I did warn him that we're going to be very protective of Constellation. Okay. That looks like a reasonably small delta. Okay. Yeah, I just pushed that. I gotta also tell the guy via email that the thing worked. What do we put on the bottom left is going to be the question. Interesting results might be next research direction. Glad to hear that. If you find anything that you think would be useful for Puffer as a whole, let us know. Or if you have any cool environments. Always looking for new benchmarks. So this bottom left part, this bottom left plot, actually, let's pull it up on the website so people get a better idea, because that looks way better. So we had this nice T-SNE, right? I do think something with hyperparameter importance. Phone app, new task, view config keys. Related to risk? Yeah. If you've seen Finn's demo, he does actually have some puffer policies on a real drone. It's pretty cool. I'm gonna use the restroom real quick. Or actually, no, I'm just gonna walk around and get myself a drink, I think, real quick. I have an idea in the meantime. Let's try something. Okay. Can't use protein. Yes, I did mention that. You don't one thing that we found very early is you do not want to trust the Gaussian process directly. You only trust it to select the experiments, and then you interpret the experiments directly. You don't interpret what the Gaussian process says about the experiments. That is what we have found. Yes, we could do a loading feature for it, to be fair. Yes, that is a thing. Um, that may be useful. The main reason I haven't done that is for fear of contaminating experiments. Like if something gets changed in the middle. I definitely agree that could be very useful though. We still don't really have a good way of doing that across M's though, which would be the most useful. But yeah, making it so that we start getting some reasonable suggestions immediately instead of after 100 runs, that would be pretty damn good. There's probably a way to do it. Use the restroom and grab a drink real quick. We'll fish for a couple ideas for Constellation. And then we have some environments to fix up. We've got some sweeps to set up. A few different things to do. I'll be right back. All right. You could do that. Mm. I mean, the biggest thing would be is if you could just like take all the ends, right, and somehow get a starting point for your sweeps out of that. That would be really big. I just don't see any way to do it. I don't want to creep too much into this update, to be fair. We have the puffer mascot changes, no big deal. We'll figure that out. I think other than this, it's just the sweeps. There are lots of things that we still would like to have that aren't fully there yet. But I think this is okay at the moment. Figure out hypers. Oh, if we don't find anything, one thing that we totally could do that I am fine doing is we could just punt on the T-Snee, and we could just ship Constellation um with like pre-baked T-Snee or whatever set of baselines we release. We do have self-play. The new puffer is not great yet, Arch. We're having problems with it. It's very frustrating to me, actually, with the amount of money that we spent on modeling. It is, like, working with artists is kind of like working with programmers, in that, like, some of them are just awesome, but unless you really know your stuff as an artist, you don't have a way to tell who is actually good, even based on their portfolio, believe it or not. Um, and the bad ones are just, like, the bad ones are just awful. We've had a few very, very good ones, though, that we've worked with over time. But not in the area that we needed for this. I'm trying to come up with some other ideas for Constellation. If we normalize perf better, we could use it to plot all our ends in difficulty. Decide which design wins. The number of, like, dumb things that you get, like, back, though, I mean, it's like, it would be stuff like, oh, this puffer is great, but it's missing a fin. Oh, I've added the fin back. Please check on this. Cool. Now it's cross-eyed for some reason. Why is it cross-eyed? Okay. Hey, here, I fixed that. But now it's missing the fin again. Oh, okay. Now it's not missing the fin and it's not cross-eyed. Okay. But, like, this thing here that I asked before is still not, like, man. Compute versus difficulty. Yeah, so I was thinking of that, but then the problem with compute versus difficulty is that it would have, we could do it, but it would require us to set a threshold on perf, and it would require us to really think about how we scale perf, right? Constellation is this. I don't think if there's anything else. I guess there are a few small things I want to have done. Those are all pretty easy to automate. What manual work is left on release? I guess it's mostly just writing the blog post and then making sure results and stuff are good. As well as just having used it for a little bit more time, like using the final version for a while to make sure that it's good. See, but the problem with number of flops, right, is like for these very small models, there's a pretty big difference. Um, well, I guess we could we do that? Let me think. Maybe there is a way to control that. We could just do some basic version of this, right? Like parameters times steps approx equal flops. That might be interesting. That's actually really easy to just add to constellation as an axis, though, isn't it? Params times time. I think it would be closer to params times obs. It should be proportional to the net size, like linearly. I think it just takes forever now. This is on medium as well. I do wonder if they made it, if they nerfed the speed. Is the ocean bugged? No. What do you see bugged? This is the site. This is puff. Look, this is what I have. What are you seeing wrong? Power climb? Seems fine to me here. Takes a second to load because it's a big policy. Chrome has skill issues. Could be. I have a feeling this has come up with something dumb. The other thing we could do is we could make the constellation panel tabbable. I think it looks so much cooler like this. How it looks for you. Hang on. Yeah, it could do full view of each That's weird. I don't know why it does that. That's weird. Spearman heat map, yeah. We'll see if there's anything usable. I'm kind of just fishing for ideas. Burrito fronts? Of course you are. This entire thing is the Pareto front. Like, these are the Pareto points. I think we're pretty generous at the moment that we allow it to be Pareto in steps or in uptime, which is why you get both. So that you can plot either way. The whole algorithm, like all of protein, is built around optimizing the Pareto front. That's why it's good. All right. Where did it put them? Uh, I don't know either of those benchmarks, my guy. I don't do LLMRL, and I don't bother following it either. Okay, so it just came up with a whole bunch of ideas. What do I do? We do RL on it for everything but LLMs. We have the highest performance RL library out there. We're able to hit over 50 million steps per second on a single GPU. We do incredibly high performance simulation. We have architecture research co-designed for this as well. We have tons of demos on puffer.ai. Drones, driving, lots of games, other scientific applications as well. Superhuman policies with tiny policies you can train on one GPU or on one machine. How big is the team? Full-time, Spencer and I open source. Finn's with us for the summer as an intern. And other than that, it's just the open source community. It's a pretty compact library, but it is genuinely 1,000 times faster than other stuff out there. Why? Because this is my startup. Puffer AI is a startup. Our stuff's open source. Biggest env you can in terms of agents. The number of agents per env is not really a limitation at all. Like, Neural MMO has 1,000. You could set up a snake env with 4,000 very easily if you wanted to. I would suppose that the practical limitation is if you go above 8 or 16,000 in one environment, you start to have obnoxiously big batch sizes. But that's pretty much it. What did you see revenue coming? It's right on our homepage. We offer services professionally. We build ultra high performance environments for companies. We do integrations with our tech. We do contracted R&D. Generally, the idea is we build the best tools in the space and you're free to use them. But if you'd like to get the most out of RL, why not hire the people that built them? And we do have revenue. Puffer is profitable already. No, that's not public. What's the best way to get AI researchers? Space and struggling to find good A. Well, it's very difficult to do that in general because there's a massive bidding war, as well as many of the best ones have decided, screw it, we're doing our own thing now. Yeah, in my case, it's like the thing that I'm doing here, this has to exist. if you look at progress over the last few years in reinforcement learning, like non-LLMRL, there's basically been zero progress whatsoever on algo space, on infrastructure, on tools, on everything. In fact, I'd argue there's been negative progress in many areas. But if you look at Puffer, this exists. It's like less than 10,000 lines of code, and it's over 1,000 times faster than the standard libraries with tons of environments that are way more complex and interesting than anything that is being used in academic research or in industry right now. Um, so, like, of course, I'm just going to keep doing this because I think it's important. Yeah, yeah, it did finish, but I have to actually figure out. Okay, this is just me fishing for. I'm basically just fishing for ideas here. Is this useful? Is this just like a straight correlation? This doesn't seem super useful to me. Oh, yeah, sure. Yeah, I'll make these larger. We're trying to figure out what we want to put on the third plot of Constellation because we have to replace it with something. Way to connect. Jay Suarez at Puffer at puffer.ai for professional inquiries. You're not going to be able to hire me directly for like a different effort. The business does if you need a custom sim though or something, you can hire Puffer. We have a little bit of availability at the moment. Our next big release is coming out in the next few weeks as well. Yeah, I don't think that this is interesting, right? This is just saying that, like, I guess there's this replay ratio correlation, but this is so noisy. And this is noisy on a lot of data as well. Like, this is not good. What is this? Hyper versus long run score. Again, this is like the same thing. I think this is literally the same thing. Oh, here we go. Hyper with Pareto proximity. No. Barcode. What? Some correlation. I mean, the thing is, it's like clearly too noisy to be anything. Pooled across games. Well, I mean, just looking at this is nothing. This looks cool, but does this tell you anything? I think this just looks cool. This is like the type of thing where maybe because this is not super noisy. Chat miss? Did I miss something? Did I miss a message or did Did it not show up? You'll not be oh, my bad. You'll not be interested in RL for LLMs. Massive. Yeah, but there's plenty of people doing that stuff already. There's 0 people doing what I do. So basically, if I do not build this, this tech will not exist. And I think that the stuff I'm building at the moment will be equally as important as LLMs. Whether it makes the same amount of money as LLMs is another story. I think it'll make plenty. But regardless, I think it will be equally as important. What time is it for you? 2:34. Okay, something like this is a maybe. Maybe. Night. Infra. Yeah, but that's what we fixed here, right? Now we just have really good infra. What is this? Not particularly useful, right? Partial dependence. Long run score percent versus hyper quintile. Pooled across games. It's too much information, man. Seven? What's this tell you? What's this tell you that our, like, existing plot doesn't tell you? I mean, there's not like a global, like, Dylan MIT PhD registry or something. It's kind of just a bunch of people out there in the world, you know? I am actually thinking about doing like some flop scaling thing. Talent scouting is it? Yeah. I get tons of emails from people like trying to hire me for just random stuff. A lot of like random finance stuff as well. Just like meh. Benchmark that puffers. We have lots of benchmarks. The problem is we keep solving all of them too fast. More business guys, see? Aren't you monetizing it? It's not our business model. Because the benchmarks out there for typically for LLMRL, like our plans are pretty simple. Like we crack really fast, stable, consistent RL, and then we go use it to solve a bunch of hard problems that matter, and mostly in hard science, a few other areas. Yeah, but everybody's building benchmarks for the frontier labs already. Like, there's nothing unique about what we do that is specific to, like, would be great for frontier labs specifically. Like, yes, I could easily build a ton of benchmarks that would be useful to them, but they wouldn't advance the core thing that we're doing. So, I mean, on the business side, then surely you can appreciate the value of not getting distracted by things that are not your core company, right? There's always going to be some shiny thing that everybody's doing that seems to have lots of money around it, but that's not what we do. Plans on extending algo at PPO. We have a few plans, but frankly, Reza, I've gone through all of the off-pol lit for the most part. Uh, the biggest section of the world modeling lit, several other random algorithmic areas, and I've probably at this point gone through a half dozen of the most promising possible areas and tried stuff out on Puffer. The majority of the literature is wrong, like just straight wrong. Their baselines are super easy, so it looks like their algorithm does something, but then you put it on top of a good baseline and it does nothing or worse than nothing. To the wave. So our agents that we develop are, let me calculate, million, billion, somewhere between, I guess if we're going to talk usable agents, um, we're probably somewhere between 10,000 and a million times faster than the agents that are out there. So it's a completely different problem regime. It seems like basically impossible that you're ever going to be able to use LLMs to solve the stuff that we solve efficiently. I mean, you can light money on fire to force it, I guess, but it's going to always be like at least 10,000x the cost. Risk sensitive RL lit. I actually know one guy in constrained RL who's very good. I think he's in his like second or third year PhD now. It's pretty tough in general though. Um I think a lot of the lit that's focused about exploring safely is not as applicable because you're always just going to be training in sim anyways. Okay, guys, I do want to actually solve this today. What about some sort of, yeah, some sort of compute visualization, I think. We could actually, somebody asked about MFU before. We could actually do that. Is that not... That might be a good addition to the top right chart. Do we have SPS on here? To be honest, not a white space. Yeah, it's, again, the type of stuff we do is very different. Let me give you an example. These cars here are controlled by a self-driving model that's trained in simulation using Pufferlib. This is the highest performance open source self-driving simulator that is available. You literally only need a 1 million parameter network to be able to train a good self-driving policy. And now this simulator, as well as Puffer as a whole, is being used by multiple different self-driving companies, including deploying on the road. No form of an LLM ever makes sense for this. I'll go change. Jess, it's not an algo change. It's just a an optimized kernel for longer sequences for the min-grew scan. It's just parallelizing the loads. It turned out to look very fancy, but it's pretty simple. It's like 100-line addition, and it's plus 10 to 20%, depending on the sequence length and stuff. It's pretty decent. LMMO train. Nope, one policy. Independently controlled separate policy. Got miss? I replied on that info, please. Agent orchestra. Like, that's again, I meant that that's an entirely different space because those are all language agents. It's not what we build. Like, we have multitask training and stuff, but it's a very different space. Like, our version of multitask training would be something like this. This is a racing policy for a drone. If I just hit, if I hit tab here, oops, wrong one, hang on. So yeah, this is a racing policy. If I hit tab here, formation, different formation. This is the same neural net, the same policy, just given different instructions, essentially. Oh, yeah. That env is, work by our intern. It's also tiny, far less than 1,000,000 parameters. You can run it on a potato. Different policies for different agents. M's where you need to train. Hang on. I don't agree with the premise. Why do you need to train different policies? Why do you need to train different agents for optimality? It's not that it's outside of the scope of Puffer. I reject the premise. Sound like my uni professor. I speak so incredibly casually and without care compared to how I used to talk. This is considered me getting sloppy on my comms, as I've just gone super deep into the tech side in the last few years. I still try to think very clearly about all the problems that I'm working on, though. That I've probably gotten better at. I tend to have a very clear picture of what I'm doing and why. I'm thinking something about the perf of Puffer as evaluated on all these ends would be nice, right? In touch with any potential clients. I mean, we're mostly looking at large companies that have substantial reinforcement learning projects that they would either like us to do for them or revamp for them or what have you. And specifically non-LLM-RL, right? We're really not looking to expand into LLM stuff. No, I don't think so. There are still lots of companies that have non-LLM-RL projects. The typical message when I talk to companies, it's like, "Yeah, we tried it, it was hard and we couldn't figure out how to do it." And then I tell them, "Well, we're doing it and our stuff runs 10,000 times faster than yours did, and here's the proof." So, that gives us quite a bit of a leg up. And then they say, "Oh, okay, well, let's try a small project to see how this works." And then we've like solved their problem in 2 weeks, and that's typically how we get started. I'm trying to think exactly the plot that I want. I guess just model size. Honestly, what if it's just model size versus SPS? I think it is just SPS, right? This median is dumb. That's interesting, potentially. Nope. You'll be okay seeing our research and giving us review. I mean, with stuff in my domain, yeah, we have services. Um, Not like general ML or general AI review though. Does X message? Let me check the Discord. Hang on. Jen, drone env has variable setting for the mass, and it differs across drones. So in constrained RL, if controlled the movements, then heavier drones should move less distance. Yeah, I mean, we intentionally randomized to make our agents more robust. It's not harder, it's actually easier. The way to look at it, it's kind of a form of sys in a sense, where like whatever shape and mass and whatever the drone has, it's gonna fly around a little bit, and it kind of just takes its first few shaky steps and then says, "Ah, okay, this is how the physics roughly work," and it flies fine from there. It's a pretty cool approach. Fine tuning open weight models. Yeah, again, that's outside of my domain, man. You don't need like a giga specialist in RL for that. That's pretty generic work. Do you know any real world industrial applications use RL for mission control? I don't, but it will definitely be used there. I think the main problem is just RL being janky and not working if you try to do stuff with SB3 or whatever. Violation of wait, solving. IPO didn't solve was violation of budget use. What's that mean? What would not be generic work? Sure. So the general services that we offer, the services that we offer that tend to be like the main thing that companies hire us for, we build ultra high performance simulations for specific tasks and problems. We've done stuff in defense, animation, games, finance, commerce, and we build sims fast and in a way that combines well with RL. We have helped integrate our RL stack on existing environments as well. And then we've also done contracted R&D where a problem is well suited to RL, but it needs something that's just sort of slightly outside of the normal set of applications and has needed us to develop some slightly varying techniques to account for. Those are the types of things we typically do. I guess this is interesting, right? We could try to get like MFU by param count. Yeah, thanks for dropping by. Let's say you have a budget limit for the entire team. What do you mean you have a budget limit for the entire team? Like, budget of what? Energy, money, actions. Wait, were you trying to do that across all drones? Because you can definitely do that for a single drone. If you're trying to do it across the entire, like all the drones, then yeah, you've created like a massively difficult coordination problem. You would just like try to have them optimize their individual budget. Okay, right, but like you'd need to give me a practical instantiation of that, right? Because if you just want them to like go through the rings while minimizing fuel or minimizing like redundant movement or something, like the solution is going to be pretty much the same if you do it individually or if you do it jointly, but it's going to be dramatically harder to learn jointly. So if you have a joint problem, then there needs to be a meaningful joint solution. And then specifically, if you are just using drone as a proxy to study this problem, I would make an env that way better models like the specific thing that you care about because you have the whole control learning thing in the mix with drone. Like here's a very very simple environment by the way that shows like some level of multi-agent awareness. I'll give you a really simple example. This is from our new demo, like our new like template environment. So there are multiple puffers. There are multiple targets of each color. The targets go on cooldown when you hit them, so you have to spread out and hit different targets of your color. So if all the agents just go to the nearest one and they ignore what the other agents are doing, they will undersaturate and they'll have a bunch of them off cooldown. This did not require any custom algorithm work. It just required a slightly custom encoder because the agent could not see correctly. All right, let me use the restroom real quick. That should solve it. Yep. I have a maze. Wait. Maze where robots in a grid. Some frequency. Probably if you set it up correctly, yeah. I'd have to see a version of the env. Oops. Only special thing. Safe etching that costs 1. Oh, okay. That's interesting. I mean, I could give you some advice on how to formulate that. Were you the one that submitted all the envs recently or no? Is this you? Oh, if this is you, then I can probably help. Yeah, so I guess why is this... My first question to you is why is this specifically a multi-agent problem, right? If you give me some like simple formulation of this that I can read through, I can sanity check it for you. Yeah, replay ratio 1 is going to be the issue, right? Mm-mm. Probability. That's probability of what constraint is greater than a constant. So you violate the constraint of some fixed budget less than alpha% of the time. He is total team cost. Okay, but is it a team problem is the question that I have, right? Because if you're going to ascribe a joint multi-agent objective over something that's clearly the agents don't interact in any meaningful way, you see the issue? That's like basically saying, hey, if I put you in a box somewhere and then there are 9 other people in boxes otherwhere that are solving your same problem, like how do you optimize stuff such that they don't break the constraint? It's sort of a screwy setup. There's probably some optimal joint thing you can write down for simple cases, but that's fundamentally like not a learning problem. Like if you can't observe your teammates spending budget, right, as they're spending it, then what are you supposed to do? So if you want this to be a joint problem, then it has to be a meaningful joint problem. It can't just be something where you can write down an oracle solution that's not learnable within the problem itself by an agent or by a person or by anything, right? You can see that and learn. Okay. So yeah, I have to see a version of that to sanity check. Either if it's going to be an NPR or like whatever, however you want to do it. I don't know if you have some simple version of this that I can just like check the PR or something on later this week. Or this. Hello, Spencer. Sent Fork and Jen. Okay, let me take a quick look at this and then I'm going to chat with Spencer, I think. Okay, this is a nice simple env. So you can see Who has an unsafe action. Which env does this correspond to? Is this the maze env or which one is it? The maze. Okay, so hang on. How does this map to anything? Let me see. How does this work? Dev. Why is Discord failing now? Where did your envs just go? There they are. Well, this is interesting. Wait, are these walls? Can it walk on the dark squares or no? Does it cost, like, is it like it costs budget to walk on the dark squares? And it doesn't cost budget to walk on the gray squares? Is that it? Or is it only dark is walkable? Red with a number is reward, okay. Wait, so what's hard about this? This is like a simple maze. Oh, okay. Yeah, the issue here is because I get it. So the issue here is that it's stepping simultaneously, right? So all the agents are stepping simultaneously. So unless the budget is quite large by comparison, you're gonna like jump way over the budget in one step, I would presume. But then that's a formulation problem, right? Of having it be simultaneous. Okay, this is janky as a sequential problem, I will admit. It's janky to model this as a sequential problem. Is it? It is realistic? Not particularly, because you have a really, really big chunk of just like time discretized, right? This is like a 5 or 10 step problem that you like each chunk of time is big, and that also means that you can't like really wait for the other agents to see what they're doing. So yeah, basically the way that I would do something like this is I'd probably just have each env be one of these, and that like every step it cycles through like 1, 2, 3, 4. So maybe each env has 4 of these scenarios set up, and but on each step you only get to see and act in one of them. And then there would have to be an action that lets you just pass your turn with no penalty, at least like at the start. So you'd have to at the start be able to see all the 4 scenarios, maybe. So 1, 2, 3, 4, you see all 4 scenarios. And then you can start taking steps to try to solve optimally without allocating budget. And that'll instant solve. Yeah, that will just insta solve. Budget is updated. Yeah, but even though the budget is updated per agent, it's still simultaneous. And they can't see each other's problem either, right? Like, presumably they can't see each other's problem, or can they? Well, yeah, then of course that's not solvable. I mean, you've given them an impossible problem. I assume that the planning algorithm uses global information. Like they can do something, but you cannot optimally solve that. I would be shocked if you could using local information. Nope, the planning algorithm doesn't use global information and it solves optimally, really? How? You don't know the difficulty of your problem relative to the other agents. The goal here is that like the agents that have to spend the least cost to get the most reward should do that. And then the agents that would have to spend a lot of the budget in order to get a reasonable amount of score should not. You need information from the other agents to do that. Implicitly get that info from the budget. I don't think you do you? Well, wait, if the budget is computed based on an Oracle solve, then I guess. But that's just leaking information that they shouldn't have then. It should just be like some fixed budget. Even if you perfectly know the distribution of maps, you don't know what sample the other agents got. Like, the correct thing would be that, like, whoever has the easiest map, right, to get the most reward, should just do all of their actions. Accumulation cost. You still need to be able to see the other ends. Yeah, I'm confident I could set this up in a way that would work pretty simply. 16Ms might be kind of hard because that's a lot of coordination. I'd probably anneal it, so I'd do like a differing number of Ns. I don't think that gives you the information fully. Yeah, I think I've got to chat with Spencer now, but I think you can definitely set up a version of this that makes sense and that you will insta-solve with Puffer. Scales to 1,000 agents on this problem. 1,000 agents might actually be easier. I think actually the hardest is probably like some number in the middle. Because with 1,000, then the distribution's consistent. Hmm. Okay. I can take some time at some point to try to like fiddle with this env. It's just an env problem. I think it's a formulation problem. Spencer, you there? All right. I'm gonna end stream and go chat with Spencer, I think. I'll probably be streaming some tomorrow to be determined. Um Kind of a slow day. We fixed one thing though. I definitely have some more stuff to do pre-release, but it's pretty basic. I just have to sort of set up some experiments and stuff. Anyways, thank you all for tuning in. If you're new around here, Star Puffer on GitHub. It really helps us out a lot and it's free. I will see you around. Bye.